change the order of integration and evaluate the integral from 0 to 1. Integral x minus 1 to 1 minus x dy dx. Okay, first notice that the outside limits are in terms of x. So this is x equals 0, x equals 1. The inside limits are y equals x minus 1 to y equals 1 minus x. So if we graph this, we graph x minus 1 and 1 minus x. They're both going to intersect at 1 comma 0. And x has to be between 0 and 1. So we know we're going to be in this direction or in this area. And then it goes from x minus 1, which x minus 1 is the red line at the bottom. So it's this one. And then we're going to go all the way up and hit 1 minus x, which 1 minus x is this. So basically, this is the region that we're interested in. Now, we want to change the order of integration. So instead of integrating with respect to y first, we should be integrating with respect to x first. Okay. It's easier to do dy first because those are going to be constants. We know y goes from -1 to 1. And now for x, we want to solve y equals x minus 1 and y equals 1 minus x in terms of x. So if y equals 1 minus x, that means x is equal to 1 minus y. If y equals x minus 1, that means x is equal to y plus 1. Now, y equals 1 minus x, let's see, that's the one at the top. So this is x equals 1 minus y, and then the bottom one will be x equals y plus 1. So here we're going to use two different integrals actually. So we want to take away this one here because we know that when you do in terms of dx first, it's left to right. Okay, so left to right here. The left function is the y-axis. So that's going to be x equals 0. And then the right function is x equals y plus 1. And then it changes here at the x-axis. So we're going to limit it at y equals 0. Okay, so then we're going to continue. We're going to go from 0 to 1 in the y direction. Okay, because we just did this area. Now we want to do the top one. So y goes from 0 to 1, and then x goes from the y-axis again, so that's 0, and it hits this line right here, which is 1 minus y. And again, that's x dx dy. So we have to integrate this. We'll have the integral from -1 to 0. Now the antiderivative of x is just x squared over 2, going from 0 to y plus 1 dy. And then have to integrate x, and that will just be x squared over 2, going from 0 to 1 minus y dy. Now we have to plug in y plus 1, so it's y plus 1 quantity squared over 2. If I plug in 0 in for x, I get 0, so I'm not going to bother with that. And that's dy. And then we have integral from 0 to 1. Plug in 1 minus y in for x to get 1 minus y squared over 2. And if you plug in 0, you just get 0. We're going to integrate this. This will be y plus 1 cubed over 6, going from -1 to 0. And this will be 1 minus y cubed over -6 from 0 to 1. Plug in 0, we get 1 over 6, minus, plug in -1, that's where we get 0. So I'm not going to bother with that. Now if I plug in 1 here, I get 0. So it's 0 minus. If I plug in 0, I get 1 over negative 6. So this will be 1/6 plus 1/6, and that's 1/3. And that's going to be the answer. Okay, next problem, we want to evaluate this triple integral. First integral goes from 0 to 1, then 1 to 1, then 2 to 3 of z times e to the x plus 2y dx dy dz. Now there's a very quick way to do this problem, and it's to notice that the second integral has the same number. Okay, so they're both 1 here. We know in general, if we take an integral of something that has the same limits, let's say a to a, of some function, then this is going to be 0. Okay. So basically what happens is you get some function here that maybe depends on x, y, and z, or probably y and z, because yeah, the x will be substituted in. So you get a function that depends only on y and z, and then you integrate it, whatever that is, and then you evaluate this basically from 1 to 1. And that part's going to be 0. So this part is 0 by this thing over here. So this thing we said is 0, and then you'll be integrating 0 from 0 to 1, and that's just going to be 0. Okay. So that's going to be our answer. Okay, last problem. We use a transformation u equals y minus x, v equals y, to evaluate the integrals on the parallelogram R, which has vertices 0, 0, 1, 0, 2, 1, and then 1, 1. So this is the parallelogram that we're talking about. Okay, so the integral we're interested in is double integral over the region y minus x dA. Okay. So we want to make a transformation, and let's see, for that we're going to solve for the Jacobian first. So that's going to be partial of x comma y over partial u comma v. And we know that this is going to be partial of x with respect to u, partial x with respect to v, partial y with respect to u, partial y with respect to v. Okay, so then we'll evaluate this. So we need to first solve for x and y. So notice here that y equals v. So substitute that here, we'll get u equals v minus x. And so we'll get x equals v minus u. Okay, now we can integrate or take the derivative with respect to u of x to get -1. And then take the derivative with respect to v here, which will be 1. Now partial of y with respect to u, well, there is no u here, that's 0. And partial of y with respect to v is just 1. So once you take the determinant, you want to take the absolute value. So the determinant is going to be -1, and when you take the absolute value of -1, you just get 1. Okay. Now we can take the double integral. Y is going to be v. Okay. So we have v, and then x is the quantity v minus u. So you have to subtract that. So v minus v then is 0, and then minus -u is just u. So that's what's left in here. And we're going to go du dv. It doesn't really matter the order in which we do these. We could also done dv du. Okay. Now, the next step is to figure out the order of integration, or the limits. And here, let's make a table. So we want to convert these points. So we have x, y, u is y minus x, and then v is just y. Okay, so let's take each point. We said 0, 0 from the parallelogram, 1, 0, 2, 1, and then 1, 1. The u column, we're just going to subtract y and x. And then v is just whatever y is. Okay, so now we can graph this. So u comma v, so it's 0, 0, negative 1, 0, negative 1, 1, and then 0, 1. So you just get a nice square, side length's 1. And we'll say that this is the u-axis, this is the v-axis. And so u will go from negative 1 to 0, and then v will go from 0 to 1. Now we integrate with respect to u, we get u squared over 2 from negative 1 to 0. When you plug in 0, you just get 0, and then you have 0 minus, if you plug in negative 1, you get 1 half. So that would be negative 1 half, 0 to 1 dv, and this will just be negative 1 half. So this is our answer to the original question.